Welcome to Grade 7 Mathematics. In this lesson, we explore statistics, the art of collecting information and displaying it so that anyone can understand it at a glance. By the end, you will organize raw numbers into tables and turn them into clear, honest charts. Here is our plan for the lesson. We begin by asking what data really is and why we gather it. We will sort data into its main types, then organize it neatly using frequency tables and tally marks. After that, we will read and draw three kinds of display: the bar chart, the pie chart, and the line graph. Let us start with the foundation. Data is a set of facts we collect to answer a question. We gather it by counting, by measuring, or by asking people. When data first arrives, it is raw and unsorted, so our job is to organize it until a pattern appears. We collect data to compare things, to make decisions, and to predict what might happen next. Think of asking every learner in your class for their favorite sport. Those answers are your data, and they are waiting to be sorted. Not all data is the same, so we sort it into two families. Qualitative data describes a quality or a category. It is made of words, not numbers, such as a favorite color, a home district, or a chosen sport. Quantitative data describes an amount that you can count or measure, and it is always a number, like a height in centimeters or a number of goals scored. Quantitative data splits again. Counted values are discrete, while measured values are continuous. Knowing the type guides how we display it. Once we have raw answers, a frequency table puts them in order. Frequency means how many times each value appears. As we count, we record each answer with a tally mark, and we cross the fifth mark through the first four, so every complete group stands for 5. Counting the sports of 20 learners, football scores 8, basketball 5, volleyball 4, and athletics 3. When we add the frequencies, they total 20, the number of learners we asked, which tells us the table is complete. A bar chart turns that table into a picture. Each category gets its own bar, and every bar is drawn with the same width. The height of a bar shows the frequency, so the taller the bar, the more popular the choice. Football reaches 8, basketball 5, volleyball 4, and athletics 3. Leave an equal gap between the bars and label both axes so the chart reads clearly. At a single glance, we can see that football is the favorite. A pie chart shows how a whole is shared between its parts. The full circle stands for everyone we asked, and each slice is a fraction of that whole. A bigger slice means a bigger share of the group. To find a slice, we take the category's fraction of the total and multiply it by 360 degrees. Football is 8 out of 20, which is 40% of the circle. Pie charts are best when we care about each part's share of the whole, rather than the exact counts. A line graph is built for data that changes over time. We plot a point for each value, then join the points in order with straight segments. Here we track books borrowed from a library each day. Reading left to right, the line climbs and dips, and that rise and fall reveals the trend at once. When we plot the frequencies of grouped data this way and join the midpoints, the same shape is called a frequency polygon. A rising line means more, a falling line means less. Statistics is not only a classroom exercise, it guides real decisions all across Rwanda. The National Institute of Statistics counts the whole population in a census every 10 years. A health clinic charts its monthly malaria cases so it can order the right amount of medicine. A coffee cooperative graphs its harvest across the seasons to compare a good year with a poor one. And a school tracks attendance to find the learners who need extra support. Behind each of these is data collected and displayed with care. Before we practice, let us avoid the errors that mislead a reader. First, every bar must have the same width with equal gaps between them, or the chart looks unfair. Second, always start the frequency axis at 0, because a cut axis can exaggerate small differences. Third, check that your tallies add up to the total before you draw anything. And finally, The slices of a pie chart must fill the whole circle with nothing left over. Keep these in mind and your displays will tell the truth. Here is a quick summary of the key ideas. Data is facts we collect to answer a question. Qualitative data is categories, while quantitative data is numbers. Frequency tables and tally marks organize raw data into order. Bar charts compare categories by their height. Pie charts show each part's share of the whole, and line graphs show how a value changes over time. Now, let us check how much you remember with 3 quick questions. Here is the first question. Is a learner's favorite color qualitative or quantitative? A color is a category described in words rather than a number, so the answer is qualitative. Question 2. In a class of 40 learners, 10 chose football. What angle should its slice take on a pie chart? 10 out of 40 is 1/4 of the class. 1/4 of 360 degrees is 90 degrees, so the slice is 90 degrees. Last question, and it combines what we have learned. 3 subjects were tallied. Maths has 7, English 4, and Science 9. Which display compares these subjects best? These are separate categories, and we want to compare their counts directly. A bar chart does that best, with 1 bar for each subject. Wonderful work. You can now collect data, sort it by type, and organize it in tables. And you can display it with bar charts, pie charts, and line graphs. Take a moment to gather some data of your own and chart it. In Module 10, we will build on this to explore probability and chance. I will see you there.